two boxes are connected by a light string that passes over a light frictionless pulley. So here we have two boxes connected by a light string, passes over a light frictionless pulley, and the mass of each box also given by the problem statement. This one is 50 kilogram and this one is 30 kilogram. One box rests on a frictionless ramp that rises at 30 degrees above the horizontal. So one box, this one, it rests on a frictionless ramp, which means that there's no friction between this box and the ramp. And 30 degrees is this angle that makes above the horizontal. And the system is released from rest. So this is the whole system. And they release from rest, which means that the initial velocity is 0. They asked us to make a free body diagrams for each box. So again, in order to draw a free body diagram, we need these elements. So what is a free body diagram? Again, that's a diagram that free a body, which means that no body shown, and what we need to focus on are the forces. So once we can identify which body we are drawing the free body diagram for, then we identify how many forces acting on it, and then for each forces we need to identify that if the forces act on by which object, on which object, the direction and magnitude, then we will get it done for the free body diagram. And then here we have two boxes, the orange one and the green one. Let's draw the free body diagram for this one first. So this is has been discussed before, that we always have weight downward, straight downward, because the earth is pulling this one down. And due to the mass, as long as it has some mass and in the gravitational field, then it will have some weight, which equals to mg, which g is the gravitational acceleration 9.81 meter per second square. Okay, and here we have a rod, a string, and this one should pull the box upward, and actually we need some force that is upward, or if we don't have it, then the box will just like fall to the ground. So this is the tension. So that's the two forces acting on the object 30 kilogram, and this is the free body diagram. The second body is this one, the box that is rest on the ramp right now. And we see that there should always be weight acting on this one, downward, right? Downward, straight downward to the ground, thanks to the earth. And what else? Okay, here is rest on a plane, and this plane just happened to be 30 degrees with the horizontal. So this one is not horizontal anymore, but we always have a force that keep the box to rest on this one, and that one should be thanks to the surface. So whenever we have a surface and an object rest on it, we should have the normal force, and the normal force should be perpendicular to the surface. So that's why we have the normal force pointing this way, perpendicular to the surface, and it should be upward, right? Because it keep the object on the surface, not like this way. This way, then the object should like sink into this one, but that's not the fact. Yeah. So that's the normal force. We got two forces so far. What the other one? Oh yes, we need to look in for some direct contact. Let's see if the box in direct contact with other thing else, and yes, we have it, right? That's the rod, the string here. So then we should have some tension along the string. So in conclusion, we should have like three forces that acted on this object, and that is it. In here, the forces are not drawn in scale yet. We just care about the direction for now, so the magnitude is not like the main issues here. So that's for question A.